Welcome, my name is restructuring, and this webcast accompanies my book Data Analysis. In it, I will show you how to restructure a workfile in eViews. Now, once eViews is opened and the dataset is loaded, you will see a screen very similar to what we have right here. This is the first example file, also used in the very first webcast. Now, as far as eViews is concerned, this is simply a list of 505 observations, as you can see over here. However, it might be convenient in some cases that eViews actually knows which observation belongs to which period. We have this data already in the series month. This is not always the case, but in this particular instance it is present. We see that the first observation comes from the 7th month of the year 1963, for example. There are various ways of writing this down. But we want eViews to recognize this as well. And we can do this by clicking on proc, and this is actually the proc in the workfile. Then structure resize current page, and you'll get a couple of options related to the structure of your workfile. By the way, these are the same options you get in the last part of importing your dataset. You can do this restructuring there as well. Now, there are various possible structures for a workfile. We have the unstructured undated, that's just 505 loose observations. We have the dated regular frequency. This means that we will have each observation is tied to a specific moment in time, and the frequencies can be, well, annual, semi-annual, quarterly, monthly, bi-monthly, a lot of different options. This is monthly data, so we go for monthly. And then we can enter a start date and an end date. Now the start date would be, in this case, 1963, and then an M for the month, and then 07. The end date at last we can simply keep it as it is, because that will mean eViews will simply keep on counting the months till the end of the dataset is reached. If there are no gaps in your dataset, that works just fine. There are various other options as well, as we can also have the date specified by a data series. We could use this option for this particular dataset too. However, in general, I would not advise it for the simple reason that it's a lot easier to make mistakes with it. Dated panel is something you need for panel datasets, which is actually not covered in this part of the book yet. The other ones, the undated and undated panel, are similarly not useful for us right now. So let's stick with dated regular frequency. Of course, once again, the proper begin date, and press OK. You'll now see that the range, this is the entire set of data that eViews has available, now extends from 1963, the 7th month, to the 7th month of 2005. And if we open the dataset, data series, say BigBM3, we'll see that the dates are also mentioned actually to the left of the column. So eViews now knows which observation belongs to which period. This will make it a lot easier to deal with, for example, an outlier. Suppose that there is a problem somewhere in, say, 1987. Well, in that case, it's far easier just to add the date, to enter the date, rather than have to figure out, okay, which observation number belongs to this. So this is one part of the restructuring process which could be very convenient. Another part is that it is possible to work with just a subset of the data. And that's where the sample comes in. We now have the sample set equal to the range. So we work with all our data. Sample is the data eViews works with. We can also make this smaller. For example, if we go to proc, set sample, and here we can say I want to work with the data from, say, 1983 M07 to space, then you will have to enter the end, 2005 M07. Press OK, and then you'll see that eViews only will work with the last 22 years of data. All regressions and other analysis that are conducted will be done only on the data which fits the current sample. As you could see on proc sample, there is also a possibility to include a condition. For example, you could only use those observations for which, say, a certain return on
The resultant
the market
statistic
would be
could
positive.
be pretty much
That's
anything.
also a possibility.
Over here we see values
In
ranging
fact, there
from
are
minus
numerous ways
0.72
to make
up
sure
to
that
87.
you use exactly the data
The customary
you
cutoff
want.
point is 2. If the t-statistic is below 2 or bigger than minus 2, because the negative values mirror the positive ones, you will see a probability value which is bigger than 5%. Now, this last column, this probability or p-values, will help you make the decision whether or not a variable is significant. If the p-value is below 5%, there is less than 5% chance that we find a coefficient of this size, while the true value would be 0. In other words, if the null hypothesis that the variable would be insignificant would be true, we would be highly unlikely to find these results. Therefore, we reject the null hypothesis. So if the p-value is below 5%, the variable and its associated coefficient are significant. If the p-value is above 5%, we do not reject the null hypothesis, so the coefficient could just as well be 0, and therefore it is called insignificant. And therefore always also seen as a redundant variable which just as well might be removed from the model. It should be noted that the lower the coefficient, so the closer it is to 0, the easier it will be for a given standard error to produce a very low t-statistic. It's hard to distinguish coefficients which are very low from their value of 0, unless of course the standard error is very low as well. Now here you see that the coefficients move from values a little over 1 to a little over 1%, but that the standard errors are all in the same order of magnitude. So therefore we get different t-statistics, and therefore we can say that some variables are in this case quite good, and some variables are not as good. C4, the S&P in this case is not significant, could just as well be dropped.